All right, what we're going to be doing today is we're going to be testing the diode bridge of the main board. The unit we're working on today is the A7SCP18. This is going to be the 2 and the 3 ton platform. We are confirming that we have incoming voltage. As you can see on the meter, that's 235 to 236 volts. That's our incoming power. At this point, we'll go ahead and we'll transition from the incoming power to look at the diodes. Okay, so we've identified we have our voltage incoming. What we now want to do is we want to turn our meter on volts AC. After we've done that, we want to put the black lead on one here. I'm going to put our red lead on the other. And as you can see, we should read 208 to 230 volts. And on our meter, we have 236 volts AC. After we have identified our AC volts coming in, at this point we want to check our DC volts to verify that the inverter is operational. So we want to turn our meter on DC volts. We want to put the black lead on the negative terminal at the bottom. We want to put our red lead on the positive terminal at the top. And you should be reading 320 volts DC plus or minus 30 volts DC. As you can see here, we're reading 321 to 323 volts DC. In a situation where you have 0 volts DC, there is a 4-part test to test the diodes that we want to do. Something that's really important here is we want to be sure that as we do these tests, we're logging what we are finding. That way, when you get to the end of the test, you can compare your notes and be sure that everything added up properly. You want to power off the equipment. You want to turn your meter on diode. And then you want the black lead on negative. You want your red lead on positive. And what's good to note here is you could have an OL reading or a reading of 0.3 to 0.7 volts DC. After you have that reading, you want to move your red lead down 1. And you want to be looking for the 0.3 to 0.7 volts DC or OL. As you can see in our test here, both tests produced an OL reading. The second part of the test, with the power still turned off on the equipment, with our meter still set to diode, we want to put the red lead on negative. We want to put the black lead on positive. And then you should read 0.3 to 0.7 volts DC. In this case, we have 0.482. Move the black lead down. These readings should all be the same. As you can see here, we have 0.48. If all of them are the same or all of them are reading OL, in other words, if test 1 and test 2 give you the same readings, then that is a faulty diode bridge. On to diode bridge test part 3. We still have the power off on the equipment. We still have our meter set to diode. Now we want to take our black lead and put it on positive. We want to take our red lead now and put it on negative. And when you do that, you should have a reading of 0.3 to 0.7 volts DC. Now from here, we want to move the red lead to the other. You should have 0.3 to 0.7 volts DC, and that should be the same, or these readings both could be OL. Now on to diode bridge part 4. We still have the power off on the equipment. We want to set our meter to diode. We'll take the red and go to the positive terminal. Take the black lead and go to the negative terminal. This should read 0.3 to 0.7 volts reading DC, or it can say OL. As you can see in this test, it says OL. Now move your black lead down, and you should read 0.3 to 0.7 volts DC or OL. They should all be the same. If test 3 and test 4 are the same, then you have a faulty diode bridge. In this case, after doing all 4 parts of the diode bridge test, all of our testing has passed. In this case, we have a good board.